Yes, welcome to DC Economics. I'm going to take you through variance of discrete random variable. So we are going to look on how we can calculate the variance of discrete random variable. So far, let's begin by understanding what is discrete random variable. Discrete random variable is a variable that takes only a countable number of distinct values such as 0, 1, 2, 3, up to 4, and etc. So if a random variable can take only finite numbers of distinct values, then it must be a discrete random variable. For example, if the probability of x is equal to 2, and the probability of x is equal to 1, and the probability of x is equal to 2, and probability of x is equal to 1, and probability of x is greater than 0, and probability of x less than 0 is equal to probability of x is equal to 0. So required to find the variance of value, or expected mean, and the standard deviation. Now what you need to understand, the probability of x is equal to 2 up to the probability of the constraints up to probability of x is equal to 0 is given by taking the values that there is -2, -1, 0 up to 2. So probability of x is equal to 2, probability of x is equal to 1, and probability of x is equal to 2, and probability of x1 is equal to 1, probability of x greater than 0, that is probability of x less than or equal to probability of x is equal to 0. So the probabilities is given by writing out the upper sides of values of x, that is the probabilities starting from -2 up to +2. So here we have the x, and here we have the probabilities of x. So x starting from the limiting factor, that is 2, -2, -1, 0 up to 2. And what you need to understand here, since we have -2, 1, 0, and we have 1 and 2 on the upper sides of values of x, and the total probabilities and the total number of probabilities is given by uh, is equal to we assume that the part A is A and the second part is A, since we don't have the number of probabilities of x. Now at the center of 0, since we are dealing with two sides, means that the A represent on the negative side and another A represent on the positive side. So this means that at the center of 0 there will be 2A, since we present out A of the two sides, that is 2A. And whereby 1 will be equals to A and 2 is equal to A. So we have assumed to write out A on the probability of x, as you can observe. So, but remember, the total probability is normally equals to 1. So the all total probabilities of the values is given is equal to 1. So let you create out taking A plus 2A plus A, then plus A is equal to 1. Now solve for the values of A. So we need to solve first for the values of A. That will be equals to 6A, which is equal to 1. Divide by 6 both sides. A is equal to 1 over 6. So let you plug in the values of A to the probabilities brackets of our table here. So here it will be 1 over 6, and we take out 2 on 2A, it will be 2 times 1 over 6, 1 over 6, and 1 over 6. So this will give out now probability of x is equal to A, which is 1 over 6, and this one is 1 over 6, and there is 2 times 1 over 6. A is equal to 1 over 6, A is equal to 1 over 6. So when we times out, what we'll obtain will be equals to 1 over 6, 1 over 6, 1 over 36, 1 over 36, 1 over 6, as you can observe. So the expectation of x will be equals to, we take out the summation of x times probability of x. So since we are finding the variance, the first part is to find the expectation, the mean value of the variance, the expectation. So the expectation is given by summation of x times probability of x, that will be equal to -2 times 1 over 6 plus -1 times 1 over 6 plus 0 times 1 over 6 plus we take out 1 times 1 over 36, 1 over 6, then 2 times 1 over 6, as you can observe. So when we equate out, the answer will be equals to 0 when you sum up. So the expectation of x is equal to 0. Now, part B, let us calculate the variance value. So it's given by taking the expectation of x squared minus the expectation of x bracket then square. So let's find the expectation of x squared that is given by taking taking the summation of x squared times probability of x. So let's find what is the summation of x squared. In order to find the expectation of x squared, we need to add another table, to develop another table of x squared, and we times the values of x squared times the given probabilities above. So when we add another table, it will be x squared. So we take -2 times -2, that is 4, -1 times -1, that is 1, 0 times 0, 0, 1 times 1 is 1, and 2 times 2 is 4. So since we take out the x squared and we times probabilities. So we take the summations of 4 times 1 over 6, then plus, we take out 1 times 1 over 6, plus, we take out 0 times 1 over 36, then plus, we take out 1 times, 1 times 1 over 36, then plus, we take out again then 4 times 1 over 6. So when you make summation over there, the expectation of x squared will give you 1.67. So the expectation of x squared is equal to 1.67, or 1/2 over 3. That is equal to 5 over 3. So since we have the expectation of x squared now, it is possible to find the variance. We plug in to our formula of variance of x, that is equal to expectation of x squared minus expectation of x, then raised power of square. So the variance would be equals to expectation of x squared is 1.67. That will give you 5 over 3. Then we minus the expectation of x. Since we solved the expectation mean value, that was 0, we square the 0 square, as you observe. So the value of variance would be equal to 5 over 3 minus 0 squared. The answer will be equal to 5 over 3. So the variance of x is equal to 1 over 3. So the variance of x is equal to 5 over 3. Now, from that point, it is possible even to find the standard deviation. So the standard deviation is given by taking the square root of variance. So when we square the variance of x, the answer of standard deviation will be equals to 1.29099,449. So this will be the value of standard deviation. So after saying so, let's mark our end. Welcome to DC Economics. Don't forget to subscribe and watch on other videos. Bye bye.